So in order to create your study area, you'll need a polygon layer that represents the water. If you're lucky, you'll find a polygon that represents the chunk of ocean that is your study area. If so, that's great. You can trim the polygon to the size of your study area by creating a cookie cutter polygon and then use the clip function in the geoprocessing tools of most GIS software to clip the polygon to the size of your study area. That process is easier, and everything we'll do here will translate easily to that situation. In my experience, it's far more likely that you'll find a map of the land, and you need to do a few tricks in GIS to create the complementary shape that represents the water where your animals live. We'll be using Quantum GIS, a free GIS program. It has amazing functionality and is a solid alternative to the commercial GIS software. So what we'll do here is create your polygon shapefile from a land polygon, one that represents the continents and islands, but represents water as nothing, a hole. So first thing to do is find a shapefile that represents the coastlines around your study area. It's worth spending some time looking for a high quality shapefile from your local area. NOAA hosts a free shapefile of the world's coastlines, which is available here. And at a very coarse scale, most GIS programs have a world map polygon built in. Please remember that these approximations are fine for designing a survey, but be sure to use proper navigational charts for safety reasons when you're actually in the field. When you have your shapefile and you're ready to go ahead, open Quantum GIS, and click the Add Vector Layer button. Browse to the appropriate shapefile and click Open. It's important to know what projection your shapefile is in. You can do this by right-clicking the shapefile you just added on the Layers tab and selecting Properties. It's also a good idea to set the project's coordinate reference system, and it's usually best to set on-the-fly reprojection by default in the Settings, Options, Coordinate Reference System, or CRS tab. Now you'll create a polygon that includes the water portion of your study area. It should overlap the surrounding land and include all the islands inside it. Click the new shapefile button. Make sure that polygon is selected. You can add fields here if you desire, but it's not necessary. You can go ahead and click OK. Save the file as something like Union Layer. This will be the layer that you'll union with the land in order to create your study area polygon. Click Save. Toggle Editing. Click the Add Feature button. Select Polygon as the type. Now use the mouse to draw out the nodes. Make a polygon that includes all the water and overlaps the land. When you're done, you can go ahead and toggle off editing and save your file. The next step will be joining the land and your new polygon together using the geoprocessing feature called Union. Under the Vector tab, select Geoprocessing and Union. Select the land polygon as the first shapefile and the polygon feature you just created as the second shapefile. Click OK. Depending on how big the file size of your land shapefile is, this may take some time for the GIS software to process. When the script is done, you should now have a new layer with land and water joined together. The next step will be to remove the land, leaving you with a polygon that just represents the water, but with the coastline cut out appropriately. Use the Select Single Feature button to select the water. Now right-click the new layer and click Save Selection As. This will save the water only as a new polygon on its own, and you should have a shapefile that is usable by distance for your study area. Now that you have a shapefile, you can pass that on to your colleagues who use the program Distance and who can import the study area shapefile into Distance to start designing your survey and laying out track lines.